Okay, so today we will discuss the failure analysis. Generally, what happens when we have a component? Suppose I take this component. Here we are going to see the IB. We will fix this bottom position and apply the pressure here. So generally there are two types of failure. First one is static failure, the second one is fatigue failure. Under static failure there are two types of failure, that is brittle failure and ductile failure. You can see that when we apply the load to material in brittle fracture, the fracture surface will be perpendicular to the load applied, exactly perpendicular, and in ductile fracture it will be with the angle to the load applied. And also in the brittle failure there will be a very less deformation before fracture, and in ductile failure there will be a maximum deformation before fracture. In this case study we will see how the two failures will have a different effect on the structure. The next one is fatigue failure. What is fatigue failure? Under repeated cyclic loading, component fails below the yield or ultimate strength. Suppose your component fails here at stress is equal to 200 MPa. Here it will in fatigue failure it will sustain only sigma is equal to 50 MPa. So what is the sigma? What is the cyclic loading? You can see that there is a sinusoidal curve. The sigma A means sigma A is equal to sigma max minus sigma minimum by 2. This is your amplitude. This is the amplitude of the stress applied, and sigma mean is equal to sigma max plus sigma mean by 2. So our specimen will be under the cyclic loading. Here we can see that generally what we see in the cyclic loading, there is amplitude stress and mean stress. It is commonly used to calculate the endurance strength. What is the endurance strength? Endurance strength means how much maximum stress your component can sustain for life cycle of 10⁶. This x-axis represent the cycle, life in cycles, and y-axis represent the sigma A. So this much of maximum stress your specimen or component can sustain before for infinite life. That is your endurance strength. So there are three different theories we generally used. First one is Soderberg theory. This theory is used for ductile material. This is used for Goodman theory is used for brittle material. we can see from the graph, this y-axis represents the sigma A and this sigma. So you can see that in Goodman there is a sigma ultimate tensile strength, and in Soderberg there is a yield tensile strength. When we compare fatigue result with the static result, in ANSYS software package provide all three types of theories: Soderberg, Goodman, and Gerber's. In software take completely reverse condition. It means when you solve your problem for fatigue in software, it will take completely reversed loading. Here we have seen that it is not a completely reversed cyclic process. This is called fluctuating stress. So in the ANSYS software, we have these three packages, and software take generally completely reverse condition where mean stress is 0. Here I have shown some results of static failure and fatigue failure. You can see I have taken this I section, and I fixed at the bottom and applied the pressure is equal to 50 MPa. You can see that at this neck portion you get the stress value is nearly about 216 MPa. Then for same condition, what we do for fatigue failure? In fatigue failure we have taken the Goodman criteria, Goodman theory. And for this fatigue failure we generally see the factor of safety is equal to ultimate upon 1 minus. So for fatigue failure we have taken the 1 minus stress. From this static failure, and now when we calculate, and we know this value as we have taken some material for the I section, then we get a factor of safety. As you can see that the factor of safety is very less in this portion, that is nearly about 0.39823. It means your material, your component fails much below this value. Also, while carrying out fatigue failure, we generally has taken the 10⁴ cycle life. So we can see that this portion will not fail, but at the neck portion, the maximum cycle life at this portion and at this portion it is 92233 minimum. So your component will not sustain the stress at this point, and it will fail at this cycle, after this cycle. Thank you.